All right, as we get started, let's go and review some things we've talked about over the last several lessons. One of the things we've been doing with proofs a lot has been to prove a couple of lines equal or to prove a couple of angles equal. And we said often one of the best ways to prove lines or angles equal, Brandon, is to... One of the best ways to prove lines or angles equal to each other is to... Adam. After you first...
State that you have two congruent triangles.
Good. Get congruent triangles, use CPCT. Class, what's one of the best ways to get lines or angles equal?
Get congruent triangles and use CPCT.
Get congruent triangles, use... What are those five letters, class?
CPCT.
CPCT. What does CPCT stand for?
Corresponding parts of the congruent triangle.
There we go. We said that if two sides of a triangle are equal, what else must be true? Back to Brandon for redemption.
And their opposite equal angles.
The opposite angles are equal. Good. We said that if two angles of a triangle are equal, what must be true, Abby? The opposite sides must be equal. Go and put the water bottle off the desk there. We said that if a triangle is equilateral, what else must be true, Brecken? It's also equiangular. We said if a triangle is equiangular, what else must be true, Josh?
It's also equilateral.
Because if you got equal angles, class, got equal opposite sides. If you got equal sides, got equal opposite angles. What did we prove about the exterior or an exterior angle of a triangle? What did we prove about an exterior angle of a triangle, Dylan?
And it's greater than the two opposite interior angles.
Good, it's greater than either one of the opposite interior angles. We said that how many perpendiculars can be drawn to a line from a point? Lana? One and only one. Remember, we used the whole exterior angle thing to prove that yesterday. In fact, we kind of did a different kind of proof yesterday with that, and in fact with the equal angles means equal side, or equal sides means equal angles thing. And we said that we were going to begin by assuming the opposite of what was to be proved. What kind of proof was that, Noah? That we did yesterday, where we said, okay, we're going to prove that only one perpendicular can be drawn. Well, let's assume we can draw more than one. Oh, no, that doesn't work out. That proves ridiculous. What kind of proof was it?
Proof by contradiction.
I'll take it. Proof by contradiction. That's not the term from your notes, but it's one of the alternate terms I gave you. What's the term I gave you?
Isn't it indirect?
Indirect proof. Anyone remember the third name? Informal. Any of those would work. Indirect is perhaps the best name for it, but proof by contradiction works great. One of the big things we said with every proof is we want to devise a strategy. Look at what we're trying to prove, figure out a strategy. What's that planning step called, Michael?
Analyze.
Well, analysis, in which we analyze, right? It's the analysis. But I said before you even do the analysis, there are going to be some statements that as soon as you see them in the given or you see them in the proof, clang! You know exactly how you're going to respond, even without thinking virtually. On the back side of your homework handout, we're going to get to it in just a minute. I want you to consider this picture for a moment. I've got a triangle XYZ. If I told you that XZ and XY were equal, number one, what is the clang response to that being given? Write it down. What is the clang response? What would be the very next statement in your proof if you found out that XZ and XY were equal? Next one, number two. If I gave you this picture and I told you that angle M and angle J were equal angles, clang! What's the very next statement you're putting in your proof? If I told you that angle J and angle M were equal, what is the next statement you would write in your proof? Number three, if I told you that QS was perpendicular to RT, clang! What's the next statement you write in your proof? If I told you that QS was perpendicular to RT, what is the next statement that you would write in your proof? Number 4, if I told you that M was the midpoint of GH, clang! What's the next statement that goes in the proof? If I told you M is the midpoint of GH, what is the next statement you would write in your proof? Number 5, if I told you that VX bisects angle V, clang! What's the next statement you put in your proof? If I tell you that VX bisects angle UVW, what is the next statement you would write down in your proof? All right, Abby, number 1, if I told you XZ equals XY, clang, what are you writing down?
Angle Z equals angle 1.
Angle Z, which is across from this side, equals angle Y, which is across from that side. How many said angle Z equals angle Y? My reason would be, if in a triangle, 2 sides are equal, the opposite angles are equal, or angles opposite equal sides in a triangle are equal. For the next one, if I told you that angle M equaled angle J, clang, what's the response, Noah? MK equals JK. MK, which is across from J, equals JK, which is across from angle M. How many had that? Or JK equals MK, that works as well. All right.
I kept writing reasons for something.
No, I don't want reasons. I want statements. What is the clang response to one of these givens? All right, so for the next one, if I said that QS is perpendicular RT, clang, what's the response? What's the next statement in the proof? Adam.
RS equals TS.
If QS is perpendicular to RT, what is our next statement?
Well, I guess we could say angle RSQ and angle TSQ are right angles.
Perfect. If you're given a perpendicular, you got right angles. Now, you might have numbered them 1 or 2 if it were you doing it, and you would have said angle 1 and angle 2 are right angles, but I didn't number a 1 and a 2, so yeah, you do what he said. Either QSR or RSQ and a TSQ or QST are right angles. How many have right angles? Clang response to perpendicular. What if I said M is the midpoint of GH? Dylan? GM equals HM. Good. How many have that? All right, what if I said that VX is the bisector of angle UVW? What would be my clang response? Brecken?
Angle UVX equals angle WVX.
There we go. Or again, if it was up to you, you'd probably number them like 17 and 34, and you'd say angle 17 equals angle 34, whatever you would do. How many have those 2 angles equal to each other? Again, that's the clang response. Why? Because if in a triangle 2 sides are equal, class, opposite angles are equal. If in a triangle 2 angles are equal, class, opposite sides are equal. Perpendicular lines form right angles. Midpoints divide a line into equal segments. A bisector divides an angle into 2 equal angles. Those are your clang statements. These are the things you don't need analysis for. If you see them, you react to them, you respond to them, you get those things down. Let's take a look at your proof now. And let's see if there was some clang maybe in the proof. Go ahead and hold it up. Should look like this, only filled in all the way. Good. Yes, excellent. Let's take a look here. So we have this kind of a diamond-looking figure here, or a kite. Let's go with kite. Kite-looking shape. And I told you this is a straight line, and that is a straight line. It wasn't in the given, but I told you let's roll off of that. And I numbered a bunch of angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The only angles I didn't number were at D because we didn't end up needing those. But if you went ahead and did 11 and 12, more power to you. For your very first statement, and we'll be a little bit lazy here for sake of time, obviously you should have written your given, Josh.
AC equals BC, BC bisect AOC.
And reason
Given.
Clang, Joshua.
Angle 2 equals angle 3.
Right, and I put that statement in there, but I shouldn't have needed to because you would have stated 2 and 3 were equal anyway. Reason.
Definition of angle bisector.
Yeah, we have an angle bisector. Definition of angle bisector. And then also, clang, Josh.
Angle 1 equals angle 4.
And how'd you know those two angles were equal?
And a triangle angles opposite equal sides.
Yeah, we were given that AC and BC were equal, so again, ignoring the midline here, if these two sides are equal, then this angle equals that angle. In a triangle, angles opposite equal sides are equal. How many perfect through the first 3? You got the claim statements? Well, you got the reasons written down technically. I gave you the claim statements. You got the given questions on 1, 2, or 3. Now, number 4, I wanted you to prove something by angle, side, angle. Lana, what do we use angle, side, angle for? That's a way we prove.
I don't know how to say. Congruent triangles.
So we have congruent triangles, right? It's a way we prove triangles congruent. So if you see ASA, you know you're going to have some triangle congruent to some other triangle. The question is, which 2 triangles are congruent? What did you have for number 4, Lana?
I don't think it's right.
So you did not have congruent triangles for number 4?
I don't know. I put angle CAE.
Yeah, no. I mean, angle CAE is angle 1 anyway, right? We just said 1 and 4 were equal. So, no, but Brandon?
Triangle ACE is congruent to triangle BCE.
No, I
BCE.
could have just put triangles.
Yeah, those 2 triangles, and we've got angles, sides, angles. So these 2 triangles here are congruent to each other by angle, side, angle. Now, that wasn't one of the things we were trying to prove. We were trying to prove 2 things. But so far, we've just been running with claim statements. So my claim statements so far were bisector, equal sides, equal angles, and it's just kind of a, hey, look at this, we got angle, side, angle. Triangle's congruent. No analysis yet at all. Let's look at what we're trying to prove. First of all, we're trying to prove a couple of line segments are equal. In class, one of the best ways to prove lines or angles equal is to get congruent triangles and use CPCTE. Well, notice that AE and BE are indeed parts, corresponding parts of these 2 congruent triangles. So then number 5, Michael, we say that AE equals BE by CPCTE. We just got their triangles congruent. That takes care of the first thing. But I went further than that. I also said, Michael, that
Triangle ABD is isosceles.
well, that's what I'm trying to prove. But with number 5, I not only said that AE and BE were equal because I wanted that here, I also put what by CPCTE?
Angle 7 equals angle 8.
Angle 7 equals angle 8. And I'll do a triple line here since I already used double lines. Angle 7 equals angle 8. All right. Number 6, we said, well, I see 7, I see 10, I see 8, I see 9. Those angles, those pairs are going to be equal. Let's go back to Lana because
Something vertical. Or no, or up.
what'd you put for your reason number 6? What'd you
I
write?
just put opposite sides of congruent triangles are equal.
Well, but these aren't sides, these are angles.
Yeah.
I wouldn't say something about opposite sides if they're
Opposite
angles.
Angles then?
But are 7 and 10 incongruent triangles? No. What are 7 and 10, Lana?
They're vertical.
Then let's say something about vertical
I can't
angles.
remember that.
What do we know about vertical angles, Lana?
They're equal.
So let's say that.
Vertical angles are equal.
Perfect. Vertical angles are equal.
I didn't know if that was
Yeah, that's an informal statement that we proved, so let's use it, right? We're just using things we've already proven. How many still perfect? Anyone still perfect? All right. Any questions so far? Now, the next thing I wanted you to do was I wanted you to use a substitution. What substitution do you suppose we should make here, Dylan?
Angle 7 equals angle 8.
Yeah, the fact that 7 equals 8, because right here, in place of angle 7, I could put what, class?
Angle 10.
And right here, instead of angle 8, I could put what, class?
Angle 9.
So what is my statement for number 7 then, back to Dylan?
Angle 10 equals angle 1.
And so then we know, I'm going to go color here, we now know that this angle 9 equals this angle 10. Now, let's think about what I'm trying to prove here. I'm trying to prove that ABD, that's this triangle down here, is isosceles. What would it take for this thing to be isosceles, Josh?
At least 2 equal sides.
At least 2 equal sides. Perfect textbook definition. Which 2 sides do you think we're going to get equal, Josh?
BD and AD.
Probably BD and AD. If those 2 sides were equal, and they kind of look equal, then it's an isosceles triangle, correct? What would it take to get these 2 lines equal, though? Well, class, what's often the best way to get lines equal? Congruent triangles and then CPCT. So which 2 triangles, if they were congruent, Lana, would allow me to say that AD and BD were equal? Which 2 triangles, if they were congruent, would allow me to say that AD and BD were equal?
Those. Would it be a number?
No, triangle. Which triangle? Triangles need 3 letters.
ADE.
ADE, right here. This guy right here. In fact, I'll go pink on this one here. So if ADE were congruent to
DBE.
DBE. All right, DBE. So that's this one here. Right? So basically, to get isosceles, if I can get these 2 triangles congruent, then I'll have equal sides, and therefore an isosceles triangle as the whole. How many thought that through? Again, technically, you kind of don't have to put as much analysis in when half the proof is filled in for you, but hopefully you did think that through a little bit. Now, in order to get 2 triangles congruent, there's different ways to get triangles congruent. What are some of those ways? Dylan? There we go. Now, we can cheat a little bit, and we can look down the proof, and we can see which way are we going to use, class. We're going to end up using a side angle side here. So if I know this is my method, let's look at what we've got. With these 2 triangles, do we have any sides yet, class? AE and BE. Right here. There's some sides that I'm going to need. Do I have any angles? Yeah, I just said 9 and 10. So if we go side, angle, which sides have to be equal then, Abby? DE and DE, equal to itself, right? So DE equal to itself, and that was number 8, what I put down. DE equals DE, class, identity. And so now I do have side angle side, so number 9, we will state that those 2 triangles are congruent. What were they again, Lana?
ADE.
All right, now let's correspond parts here. Triangle ADE is congruent to what corresponds to the A?
B.
B. What corresponds to the D?
D.
D. And what corresponds to the E?
E.
E. Now the lettering didn't have to be exactly that, as long as the E's matched, the D's matched, and the B's matched. So you could have said bed and AED. Okay, it could have been congruent, however you worded it. How many of those 2 triangles congruent in number 9? Well, again, why did I want the 2 triangles congruent, bracket? What was the whole point of the congruent triangles again? To get these 2 lines equal to each other. So we can say that AD equals BD by... How many had that for number 10? You had AD and BD equal by CPCT, and therefore, number 11, it was done for you. The triangle is isosceles. Definition of isosceles triangle. Was anyone perfect on the proof? That was a longer one too, 11 steps. Again, I know I did about half of it for you, but good, okay? Questions on the proof? Questions on the proof? Going once, some questions. Going once, some questions. All right, set that one aside, and let's do another one. Well, let's do another one. Gavin, it is handout number 10. We're going to do handout number 10 next. Handout number 10. Gavin, the rest of you, just the handout I just handed to you. Let's take a look at this one. Look it over. Think about it a little bit while I get some things copied up here on the board. Kind of look over the given, look over the sketch. See what they got in there.
Go ahead and try to start.
I suppose if you wanted to, go and get started. So we're given this kind of crisscrossing weird shape. It's got a whole bunch of different triangles in it. It's got 3 little ones. It's got 2 bigger ones. Yeah, I guess 5 triangles in there. Given that AD and BE are equal, and that CD and CE are equal, and that this little angle 1 equals this little angle 2. We're trying to prove the triangle ADB is congruent to triangle BEA. If you haven't yet, go and get your first statement and first reason written down. And everybody should know number 2, because there's a clang in your given. What is the clang response? Well, first of all, what's the clang part of the given? Let's start there. What part of the given is clang? Noah? This ain't clang. This ain't clang. This is clangy. And it's clangy because the 2 angles that are equal are in the same triangle. Which triangle are 1 and 2 both in? ACB. They're both in this little guy down here. And if you got 2 equal angles, clang, Noah. Which 2 sides are equal? AC and BC. How many already knew you're going to say AC and BC equal? Because in a triangle, sides opposite equal angles are equal. You knew that was coming. You should have. That's clang. Equal sides, clang, equal angles. Equal angles, clang, equal sides. That was the theorem we looked at yesterday, theorem 6. Now let's look at, that's all the clangage we have, right? No more clanginess going on. Let's look at what we're trying to prove. Triangle ADB. Do you see it? It's this whole thing here. And then you got triangle BEA, which is that whole thing there. You see how the 2 triangles are kind of overlapping each other? What was my suggestion? Raise of hand. What was my suggestion if triangles or figures are overlapping each other? What did I say we ought to do? Abby?
Outline them in separate colors.
Well, if you happen to carry highlighters or colored pencils, that actually had a better suggestion. Josh?
Wasn't it like you take it out? Like,
Yeah, unoverlap them.
Yeah.
So off to the side, go ahead and draw your A, B, D. And I'm going to point out that there's a little C right here. And then A, B, E, and I'm still going to point out there's this little point C right there. Well, let's just draw them separately so we can see them a little bit without all the crisscrossing and stuff. By the way, this angle right here is 2. This angle right here is 1. So I'm going to mark that as well. I'm going to also use whatever tick marks I've used previously. For instance, we have single tick marks on AD and BE. We're going to go and mark that. We have double tick marks on the CD and the CE. And we have little X's on the AC and the BC. And I'll go and put the arc markings on 1 and 2. All right, do you see how all I did was take the 2 different triangles and I placed them off to the side so I can see them a little bit more clearly? All right, see it? Now, I want to prove those 2 triangles are congruent. If I want triangles to be congruent, I've got a variety of ways. There's nothing in here that suggests right triangles, correct? So let's rule those out, Michael. What are my options? Now let's think about what do we already have in this particular proof. What's already somewhere in the proof for me? Josh?
There's sides.
Which sides?
AC plus BC.
Well, but those aren't actually sides. Those are just little pieces of sides.
AD equals BE.
Okay, AD and BE. There's a pair of sides already equal. Okay, anything else we've got?
CD equals CD.
Well, again, those are just little parts of sides. Those aren't really sides.
Angle 1.
Okay, angle 1 and angle 2. I've got some angles as well. Okay, so I've already got some angles. I've already got some sides. Now, Josh points out, though, he said, what about AC and BC? Well, those are just parts of the sides. And CD and CE, well, those are also just parts of the sides. But these 2 parts of this side are equal to these 2 parts of this side. What does that suggest maybe we should state next, Noah? Yeah, I mean, if you're cheating and looking on the proof, which I can't fault you for, right? You know what's coming next, but the bottom line is if these 2 pieces are equal to these 2 pieces, I can get the whole lines equal, right? But it starts, the process begins with the whole is equal to the sum of its parts. We've seen this a few times now, where you've got a couple pieces equal here, a couple pieces equal here. Start by stating that the whole BD equals the sum of its parts, BC and CD, and the whole AE equals the sum of its parts, AC and CE. So I gave you the statement. You gave me the reason, Noah. All right, the whole is equal to the sum of all its parts, or whole equals sum of parts, or however we abbreviate. We get the idea of the axiom, right? And then, after we've stated that the whole is equal to the sum of all of its parts, well, if these 2 pieces are equal, per statement 2, if these 2 pieces are equal per the given, then I can take equal quantities and add equal quantities to them. What would be the reason then for what I stated in number 4, Brecken? I didn't substitute anything. I just took these 2 pieces that were already equal, and I added these 2 pieces that were already equal. So these 2 things are equal, and they were 2. So the sums have to be equal. That's my class addition axiom. The addition axiom. If equals are added equals, the sums are equal. So start with the whole's equal to the sum of its parts, then get the sums equal because of the addition axiom, and then we can do what Brecken wanted to do a second ago. And Brecken, now I see the whole sum AC plus CE. Well, what is that? So I can take AE and put it right there, and equals, well, BC plus CD, but I can just go, the noise. I was waiting to see if you'd do it. BD, and that's where I do my substitution. That's the substitution. Again, get a good set of 3 steps to kind of tuck away in your mind. Whole equals sum of parts, addition, substitution. And that's to take pieces equal and get wholes equal as a result. So now I do know that this whole line equals this whole line. So there's some more sides. So thoughts, class? Side, angle, side, right? I've got sides and angles. Oh. Do you see that I do have 2 sides and I have angles, but it's not side, angle, side, class? They would have to be these 2 angles to be side, angle, side. Well, I'm at least going to rule out angle, side, angle, right? Because, I mean, if I only could get these 2 angles equal, that would be side, angle, side. Or, I mean, there's still side, side, side on the table, right? But what lines would have to be equal for side, side, side? Lana? Yeah, but I mean, I've already got the blue ones equal, and I've already got these 2 equal, so that would leave,
The AB.
would have to equal,
AB.
yeah, how would I do that?
Identity.
Oh yeah, it's the same line, right? Now technically, class, look, do you see that the B corresponds to the A and the A to the B? So here we're going to say AB equals BA, but it is because of what Lana said. What was it?
Identity.
Identity. And even though we were given a pair of equal angles at the start, which I would have assumed angle, side, angle too, it just didn't work out, but we can get, class, the triangles congruent by side, side, side. And I believe, yes, that wraps up the proof. Questions on this? Starting to get a feel for how to piece the things together. Okay? Any questions? All right, go and clear your desk if you would please, except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away. One clean sheet of paper and a pencil. Everything else off your desks. First and last name at the top of your paper, along with today's date, which is 9/28/22. 9/28/22 is today's date. First and last name, 9/28/22. And this is quiz something. Let's go with quiz 9. This is quiz 9.
I ran out of paper.
Do you have a quarter? I'll sell you 10 sheets.
I don't have a quarter. I have a wallet. I'll just give you my wallet.
Dylan to the rescue. So stock up your notebook so you've got plenty of paper in the future. Thank you, Dylan. All right. As usual, use the quiz copy as a cover sheet. Use the quiz copy as a cover sheet. Let's talk through the quiz very quickly as we are passing back quiz copies. All right. Notice number 1, any 2 triangles. So if methods only apply to right triangles, could they work for any 2 triangles, class? No. So we're not looking for any of the right triangle methods there on number 1. Several of these things in 1 through 7 are clang. So when it says, if in this picture, then, that's clang. What's the clang response? And then for the proof, like we've done in homework, like we did on the last quiz, copy the picture, copy the given, copy the prove, set up 2 columns, statements, reasons, put the entire proof on your own paper. All right? That way, when I hand the quiz back to you graded, it can act as a study guide headed toward the exam. All right, go ahead and get started on quiz 9. Yes, sir. Yeah, as long as I taught you the abbreviations, you can use them. Anything I taught you, you may use. You just can't make up your own stuff. Some imbecile. Oh. Can't believe some people making markings, even an extra big one. Don't write on it. Like this imbecile did. You're allowed to write on it, Gavin.
Imbecile.
Imbecile? Plural? Maybe there's more than one imbecile. And do use that quiz copy as a cover sheet.
I was planning for you to put it on that. You can if you want to.
Keep your answers covered best you can. Work quickly but accurately. Once you finish, just sit quietly. Still working, you still have a few more minutes. Absolutely. Absolutely. That's exactly what I want. Two more minutes. 2 more minutes to be finishing. All right, go and take out your notebooks if you would, please. Turn to the terms definition section. Terms definition section of your notebook as we round out the hour here. Spend a little bit more time looking at these tomorrow, but I want to introduce the thought to you today. This idea of what's called a converse statement. Next thing in your notes, converse statement. Converse like the shoe brand. Statement. A converse statement. Inverse means opposite. Converse has the idea of turning something around, but not the opposite, but similar idea. Here's your definition. A converse statement is a statement that is formed, by interchanging, there's a great word, a statement that is formed by interchanging the hypothesis and the conclusion. A lot of big words in that definition. A statement that is formed by interchanging the hypothesis and the conclusion. Statement is formed by interchanging the hypothesis and the conclusion of some other statement. Converse statement is a statement that is formed by interchanging the hypothesis and conclusion of some other statement. In parentheses, put this, plain English. Swap the if and the then. Swap the if and the then. That's what a converse statement's all about. You're switching the if and the then. For instance, if Brecken is in 11th grade, then Brecken is a junior. Is that a true statement? If Brecken is in 11th grade, then Brecken is a junior. If I switched it, I would say, if Brecken is a junior, then he is in 11th grade. That's also a true statement, isn't it? Because after all, that's how we define an 11th grader or define a junior, right? As somebody who's in 11th grade. We can do this with geometry statements as well. Did you kind of catch it when we did Theorem 6? Theorem 3 said if a triangle has two sides equal, then the angles are equal. If a triangle has two angles equal, then the sides are equal. Theorems 3 and 6 are converse statements of each other. Now, here's the hard part. Just because something's a converse isn't always true. For instance, if Fluffy is a cat, then Fluffy is an animal. Is that true? If Fluffy is a cat, then Fluffy is an animal. Switch it. If Fluffy is an animal, then Fluffy is a cat? Not necessarily the case, right? So in our next lesson, we're going to look at analyzing converse statements. When are they true? When are they not true? And we'll work on that in our next lesson. No homework this evening other than the usual studying that you'll do every night to keep up with all the terms and definitions and axioms and postulates and informal statements and theorems and corollaries and things from class notes as we look ahead toward an exam coming up in lesson, I believe it's lesson 43. That'll be on Friday for us, but I believe on the video that'll be lesson 43. All right, when the bell rings, you are dismissed. Have a wonderful rest of your day.